Hello. So the next part is methodology. As we can see here, this is the equation that we use in our projects. So the equation that operation that have in our equation is adding, subtractions, multiplications, power, and also divide. So the value of A that we input is 6 and B is 2, C is 12, D is 4, and also E is 2. So the final answer that we get from the equation is 16. And the next one is the coding or assembly language code in LMC that we will use for running our simulation. This is the code that we will use in adding code, this in subtractions code, this in multiply code for multiply simulation. This is the power code, and the last one is divide code. So the next one I will present in LMC simulation. Hello, my name is Muhammad Bakit Izzuddin Rahmat. My matric number is CE200150. Today I will present about our projects, concept of computer architecture and organization using simulation tool. So the simulation tool that we use in our project is Little Man Computer LMC CPU Simulator. So from our expression that we do in our projects, we have 5 types of operations: adding, subtractions, multiplication, power, and also division. So the first operation is addings. As we can see here, this is the coding that we use in adding operations. So the INP instruction is used to input value from the user and store it in a memory locations. And the next one is STA instruction is used to store the value in the num1 memory locations. The add instruction is used to add the value stored in num1 with the second value input by the user. And the out instruction is used to output the result of the additions. And the last one is #lt instruction is used to help the execution of the program. So we will run the program. The first input is 6 and the second input is 2. And we can see the output that we get is 8. So the next operation is subtractions. Subtractions from the coding, the INP instruction is used to input the value. So the value that we use in subtraction is 12 and also the second value is 4. And the next one, STA instruction will store the value in the num1 memory location and the second value in num2 memory locations. So the 12 we will store it into the num1 memory locations, and 4 we will store it in num2 memory locations. So the next instruction is LDA instruction, used to load the value stored in num1 into the accumulator. The sub instruction is used to subtract the value stored in num2 from the value in the accumulator. The out and the HLT is same as adding operations. We will run it, and the first input is 12 and then the second input is 4, and we get the 8 value from the output. The next one is multiplications operations. As we can see, this is the coding that we use to multiply the operations. So the first instruction is input the value for the num1 and num2. So the value is 8 and also the num2 is 8. And the STA instructions, we will store the value in num1 and num2 memory locations. So the first num1 egg will store in num1 memory location, and also another egg we will store into num2 memory locations. The next one is the loop instruction is used to start a loop where the operation inside the loop are repeatedly executed until the condition specified in the BRP instruction is met. The LDA instructions is used to load the value stored in the memory locations total into the accumulator. The add instruction is used to add the value stored in num1 to the value in the accumulator and store the result in num2. The BRP instruction is used to check if the value stored in num2 is greater than the value in num2 and store the result in num2. The BRP instruction is used to check if the value stored in num2 is greater than 0. And if it is, the program will jump back to the loop instruction, and otherwise the program will continue with the next instructions. So the out and HLT instruction is same as previous operations. As we already input the value, the num1 is 8 and the num2 is 8 also, and the output that we get is 64. So the next operation is the power. This is the coding that we use inside our power operations. So the input instruction is used to input the value, same as the previous operations, and also the STA instruction is used. So the coding that we use in here is different from previous operation because just we change the memory locations SB, Y, number 1, number 2. So the STA instruction is used to store the value in the B memory location and then load the value into the accumulator and store it in the Y memory locations. The loop instruction is used to start a loop where the operation inside the loop are repeatedly executed until the conditions specified in the BRZ instruction is met. The LDA instruction is used to load the value stored in the memory location Y into the accumulator. The BRZ instruction is used to check if the value stored in the accumulator is 0, and if it is, the program will jump to the AND instructions. Otherwise, the program will continue with the next instruction. The sub instruction is used to subtract the value stored in 1 from the value in the accumulator and store the result in Y. The adding instruction is used to add the value stored in B to the value in ANS2 and store the result in ANS2. The BRA instructions is used to jump to the instruction at the label loop. The AND instruction is used to the mark of the end of the loop, and the out also HLT is same as the previous. As we will run the program and the input is 2 to the power of 2 we will get 4. And the last operation is divide operation. As we can see here, this is the coding that we use in divide operations. So the INP and STA is same as the previous operations, adding, subtractions, and also multiplications. And also the loop here instruction is same as the instruction from operations adding, operation multiplication and subtractions. And the subs instruction here is used to subtract the value stored in num2 from the value in num1 and store the result in num1. So the value of num1 is 64 and the value of num2 is 4, and it will store it into the num1 memory locations. The add instruction here is used to add the value stored in 1 to the value in ANS and store the result in ANS. The BRA instruction is used to jump instructions located at the label loop, and also the AND and also the out instruction is used to output the final count stored in ANS. The sub instruction is used to subtract the value stored in ANS from itself and store the result ENS. The HLT instruction is used to help the execution of the programs. So as you can see here that we already run the program, and the first input we put is 64 and the second one num2 is 4, and the output that we get is 16. So that's all from me for result and analysis for the LMC simulation. Thank you.
Assalamualaikum. My name is Muhammad Khairi Shafiq, and I will present about discussion and conclusion for my group project. For the discussion in this project, we have been given the task to simulate the project using Little Microcomputer or LMC. We learn about register in LMC, which is program counter that holds the address of the next instruction to be executed, accumulator, memory address register, MAR, and memory data register, MDR. The LMC also has instructions that can be used in assembly code. We can see that we are using different assembly code to generate different simulation. The best way to learn the LMC is running set of codes from the simplest to the more advanced scheduling. Rather than trying to understand the simulator fully at first, this is the approach adopted in this project, which is INP for input data, ADD for add data, SUB for subtract data, STA for store data, LDA for load data, BRA for branch to specify cell, OUT or out for output data, HLT for break application, and DAT for treat content as data. So for conclusion, finally, we should be able to understand how to using the Little Microcomputer, as well as how to develop and run simple programs. We managed to study method of how to familiar ourselves with the technique for using Little Microcomputer. We also can generate the output for the equation on LMC as same as manual calculation. This project can be done because we already have understand how the LMC works and how to use it on doing calculation by using the software. We also able to derive the assembly language code to express the equation and make a simulation of execution the equation by using the Littleman computer simulator. Overall, this project was a complete success. Thank you.